Hi, you're watching AC's 8-Bit Zone. This episode is the Composite Video and S-Video mod for the TRS-80 Color Computer 2, or CoCo 2. Today I'll be modding my oldest CoCo 2 to add composite video, and then I'll mod my middle CoCo 2 to add composite video plus S-Video. There's a lot to cover and a lot to learn, so we better get started. Here we go. Okay, this mod is going to work for any of the CoCo 2s that I'm aware of. Here are three of the CoCo 2s that span the spectrum from really old to really new. The oldest CoCo 2s had the melty keys, and it had the badge that said Radio Shack rather than Tandy. And particular to this episode, the RF modulator was a vertical version. So the channel selector switch was vertically above the TV connection. The middle CoCo 2s upgraded the keyboard to the full travel keyboard. It still had a Radio Shack labeled badge, but now the RF modulator is flat or horizontally mounted on the PCB. So now the channel selector switch is beside the TV connector. And then in the last version of the CoCo 2s, the main difference was the badge now says Tandy, and somewhere along the way also the video chip was upgraded so that it allows true lowercase characters. The layout of the RF modulator is still horizontal. And if we directly compare the backs of the oldest one and this newer one, the port shifted to the left, and you can see the difference in the RF modulator location. So these two computers are going to be modded today. This is my oldest one, and this is my middle one as far as serial number and age. So this computer is going to get a composite video output, and this one's going to get composite and S-Video. Fortunately, no matter which version of the CoCo 2 you have, all the mods that I'm going to show you today will work on any of them. I'm just choosing to do only composite on the old one, just as a matter of choice, and making composite and S-Video on the middle one. But you can do anything that you'd like, and there are a lot of options, as you'll see in just a minute. And here's a view of the two modulators with the mods in place. This is the older modulator that actually is mounted vertically on the PCB like that, and then this is the newer modulator, which is quite a bit smaller, and it's mounted horizontally just like that. Now let's take a look at the new connector layout. So this has been left alone, so this is the composite video out, and I've removed the channel selector switch from the PCB and then rounded out the rectangular opening and soldered a new audio connector in place. On the newer module, I desoldered the old RF output and replaced it with a PCB mount S-Video connector. And in this model, the channel selector switch was external to the RF modulator, so that's the reason for the cabling over to a separate jack. This is a audio video jack for a 3.5mm plug, And we have composite video and audio available on the 3.5mm, and we have S-Video on the 4-pin S-Video plug. Here's a closer look at the old RF modulator and its composite video mod. Okay, in the center is the RF modulator itself, the MC1372P. We need that part, but almost everything else has been removed, and if there are a few new components, particularly this circuit in the lower left corner, which is an amplifier that we'll go into in just a minute. The audio connector is soldered into the shell, and also formerly the RF area that was shielded with its own little separate mini enclosure, the enclosure has been removed. It was sort of like a wall that was here before, and that wall has been moved, and some new componentry and some new circuitry has landed in that old area. And here's the newer modulator. This modulator also was based on the MC1372P, and as you can see, there's a lot more going on here, and that's because this has a complete separate dedicated circuit on the left for composite video and another dedicated circuit over here on the right for S-Video. Today we're going to look at two different ways to make composite video and one way to make S-Video. So I'm calling this composite video mod number 1, and there's another composite video mod that's a lot simpler than this that just involves a diode and a capacitor, and that will be what we'll call composite video mod number 2. So now let's back up and take a look at the circuits and how to make the mod, and then we'll get these installed in the Color Computer 2 and look at some display quality. Okay, to understand the mod, we need to backtrack to the schematic and then to the data sheets to get a good understanding of the theory and the principles of what's going on to generate the video. So let's start with the Color Computer 2 schematic that I have up here. This is the Rev A schematic. And right here in about the middle of the page are the pair of chips that are responsible for creating the video display output. One is the MC6847, which is the video display generator, or VDG. The other is the little metal box that's represented by this rectangle, and inside this RF modulator box is the other companion chip to the MC6847. In here is the MC1372P. There is a color A and a color B, and then there's the Y. The Y is the luminance plus sync signal. And then there's, it's labeled CHB, but this is a reference. Let's go back to where the color generation begins. So in the beginning there's an R, G, and a B value. So there's 3 separate values for the 3 components of color. When color first came into the mainstream in newer electronic devices, the engineers and scientists were pure genius. They came up with a scheme that was backward compatible. So they created the Y signal, which is the black and white component of the video. So R, G, and B are combined to give an overall brightness. And they use a formula that works so that the Y signal is the black and white signal that is backward compatible with monitors that did not yet have color capability at that time. And then what they do is, from the brightness signal, they subtract the red. I think it's the red and the blue. I may have the wrong colors, but they subtract one color from the overall brightness, and that's the A, and then they subtract another color from the overall brightness, and that's the B. And then from these three signals, the entire image can be reproduced in full color. Now this reference is the reference that's used inside the MC6847 to make those difference voltages. So they just go ahead and bring that signal over to the MC1372 as well, and that's so that if there's any temperature drift or drift over time, that it just helps tie these two chips together better to just send that reference over there. But the image can be recreated from the Y, which is again is the overall luminance and synchronization information, which is enough to actually form a black and white image, plus the A and the B color information, or the chrominance. So luminance plus chrominance make up the entire video. And in fact, S-Video is 2 signals rather than 3. So where RGB was 3 signals with separate lines for synchronization, S-Video is two signals only. One signal is the Y, or the luminance, and it also contains the synchronization information. So you get your vertical sync and horizontal sync pulses embedded in the Y. And then the second signal in S-Video is chrominance, and it's a combination of the phase A color and the phase B color. So these signals go over to the RF modulator box into the 1372. Now let's take a look at the 1372. Here's its data sheet. This is the MC1372. This is a color TV video modulator. And notice one thing that it mentions is composite video generation capability. Okay, let's just have a brief overview of the theory of what's going on here. So here's that color A input, and here's the color B input. There was the reference voltage, and the 1372 combines the A and the B and creates an output on pin 8. This is the chroma signal, and this is usually just fed right back into pin 10. Not directly, but there's an RC circuit it has to be AC coupled with a capacitor, and then the resistor is to attenuate the voltage levels to be able to fine-tune the voltage level. So this RC value connects the output from 8 right back into 10. Then here comes the luminance input, and again this was synchronization pulses on top of the black and white video image. So the color input from pin 10 is combined with the luminance input, and the whole thing is then RF modulated to either the carrier for channel 3 or the carrier for channel 4. Now, how does it know what the carrier is? That's what pins 13 and 14 are for. This is the RF tank circuit. So outside of the 1372, you place an LC tank circuit, and those are the 2 tunable components that you saw me tuning in one of my earlier videos where the CoCo 2 lost its color. So the channel 3/4 selector switch affects this natural resonance and allows you to change the modulation frequency from channel 3 to channel 4. Okay, so the reason we're looking at all of this is it's important to see how this chip is configured by looking at pins 13 and 14 to know what mode the modulator is actually in. So if you see an LC connected across pins 13 and 14, then it's using the modulator, and the total combined image is output on a single pin, which is pin 12. Then pin 12 would go off to the VSB filter and then out to the TV set. However, if you see that the LC tank circuit is not present here, and instead there's a diode, and it can actually point in either direction, from 13 to 14 or from 14 to 13, that indicates that the modulator is not being used, and this whole chip is just there to combine the A and B color into a chrominance value. Okay, now let's bounce back to the schematic. So here in the Color Computer 2 with the 1372 inside of the RF modulator, the tank circuit is in place in there. Then the 1372 in this board is being used as a RF modulator, and it's sending the signal to the channel 3 or channel 4 carrier via this RF output. Now let's briefly go back and take a look at the CoCo 1. Notice here that here again is the VDG with its reference, phase B, phase A, and the luminance. But now then the MC1372 was on the main board. And you have to run over here and up. There's an amplifier circuit, and then here is where at pin 1 it actually enters into the little shiny metal box of the RF modulator itself. So this was an old school modulator that needed the color, that needed to have the luminance and chrominance already mixed. Notice here, so like we were saying, there's no longer a tank circuit here on pins 13 and 14. The LC has been replaced with a diode. And if the diode points, if the anode is on pin 13 and the cathode is on 14 as shown here, then this is a non-inverted output on pin 12. If the diode is flipped around and the plus 5 voltage is always on the anode, by the way, so if the plus 5 is here and the diode is pointing from pin 14 to 13, then that would be an inverted display on pin 12. So on the CoCo 1, the luminance on the Y signal, the luminance or the Y signal was being mixed with the color or chrominance, sent out to pin 12, amplified, and then as a combined signal injected into the RF modulator, where it was actually modulated onto the channel 3 or the channel 4 carrier. Now back to the Color Computer 2. In order to make the mod, I needed to know a little bit more, or a lot more, about what's inside this metal box. And I was not able to find a schematic, so I had to create my own. Now again, there are the two different versions of the RF modulator box. This is the schematic for the early model, and this is the schematic for the later model of CoCo 2. Okay, so starting with the early model, let's just break this down a little bit so we understand the basic functionality of the different parts of this circuit. Okay, so pins 1 through 7 are shown here on the left, and they're numbered in order where pin 1 is the pin that's closest to the back of the CoCo case, and then they're just in order coming forward from there. So we have the 3.58 megahertz NTSC clock. It's an input into the 1372. We have the color B, the color reference, the color A, and then the Y, which is the Luma plus sync. Pin 7 is 5 volts from the main board, and it's cleaned up with a couple of stages of this LC filter. Now this whole circuit is the sound. So not only is the RF output carrying luminance, chrominance, and being modulated up to the 85 or 90 megahertz carrier, it's also carrying the sound. And this whole circuit is injecting the sound via this AC coupling cap C6, injecting it into pin 10. And remember that this is the RC that I mentioned that connects the output on pin 8 and feeds it right back into pin 10. So what it's doing is it's taking the color A and the color B, combining them into a single signal internally, and then outputting them on pin 8. That's just fed back through a resistor that can help attenuate the voltage levels, and then an AC coupling cap that's required, and injected right back into pin 10. So the sound plus the chrominance are all injected into pin 10. Then that is combined with what comes in on pin 9. So we get now we're adding in the luminance with the synchronization signals. All of that information is now in a single signal that's output on pin 12. And the and the tank circuit is providing the modulation frequency for that RF output that comes out on pin 12. That then heads over to this little filter network, and then finally out to the actual jack that goes out to the TV. Here is the channel switch, and I made the note that it was channel 3 when you close the switch, closing it to ground, and when open or not connected to ground, that was channel 4. So this is the LC circuit. So we have sound input in the lower left here. We have the tank circuit between pins 13 and 14. We have power supply filtering for the P5 5-volt rail. And then we have a filter built out of discrete RL and C components. Now let's take a look at the late model schematic. Pin 7 is now a channel input. They moved the channel selector switch out of the RF modulator box and onto the main board of the CoCo. And we still have the tank circuit, but now the filter that was built out of discrete RLs and Cs is now a SIP package. So it's a 3-terminal network, and that allowed them to greatly shrink the size of the RF modulator. But it also simplifies our work that we have to do to modify the circuit boards and prepare them for our composite video mod. Let's take a look at the data sheet again for the 1372. And in particular, they mention there's a little section here about composite video signal generation. The RF modulator may be easily used as a composite video generator by replacing the RF oscillator tank circuit with a diode as shown in figure 3. And that's where the diode is pointing from pin 14 to pin 13. This results in the output modulator being biased so the sum of luminance and chrominance appears unswitched, meaning unmodulated, at pin 12. The polarity of the output waveform is controlled by the direction of the diode. The way we're connecting it will be the inverted video option. Anode on pin 14, cathode on pin 13. And we're going to uninvert that with the external BJT amplifier circuit to get non-inverted video in the end. And then again here it talks about the increasing the load resistor to increase the amplitude of the signal. Oh, and here it's talking about what to do with pin 12. One thing about pin 12, which is the output of the total combined signal, it is a current sink instead of a voltage source. So the only way to get a voltage signal, so one simple way to get a voltage signal out of a current sink or a current source is to connect a resistor to plus 5 volts. Then a voltage will appear across that resistor. Interestingly, that is all that it says about how to get composite video, other than directing us to figure 3, which is not a complete circuit. It's just showing us the detail about the diode that defeats the RF modulation or the tank circuit. Okay, and interestingly, the place that there's more information about how to use this to generate composite video is in the datasheet of the companion chip, the MC6847. If you go all the way down, and this is the schematic, this is going to be the circuit that most of the composite mods that I've seen are based upon. So here it is, figure 27. We're in the MC6847's data sheet. Color composite video. And this is what my composite video mod is based on. It's pretty much this circuit exactly. So the diode replacing the tank circuit, and pointing from pin 14 to pin 13 is the inverted video mode. And there's a PNP transistor, a 4403, and then there's the NPN. So I'm going to show you the circuit in just a moment, and you'll see that this is almost exactly, there's just a few tweaks that I made, but this is mainly, this is the theory behind how to get the composite video. One other way to derive composite video comes from looking back at the Color Computer 1 schematic. Remember how in the Color Computer 1, the RF Modulator IC, the 1372, is not in the shiny metal box, it's on the main CoCo 1 PCB. And here's one of the tricks that was alluded to in the 1372's data sheet to get a higher output. So again, here's the pin 12. This is the output of the total combined luminance and chrominance, and it's a current source or current sink. This 3.9K resistor is sourcing from what's basically a 7-volt supply. It comes from the 12-volt rail, and then there's a Zener diode that knocks that down to, I think, about 7 volts. So this is, think of this as a 7-volt power supply rail, and having a higher voltage and then a higher resistor allows them to get a larger signal swing out of pin 12. And then they're just going through a single transistor amplifier, and they only needed this one transistor. I have a feeling that some of the other composite video mods that are floating around could be based on this approach right here. I haven't tried this one yet with the higher 7-volt rail and the larger resistor, the larger load resistance, but that would be interesting to take a look at. However, the composite video mod that I'm going to show you works pretty well. I just don't know if this one would be a little bit better or not. You would not direct this signal into any RF modulator, but you would just take this and with just a little bit more signal conditioning, probably inserting a 75 ohm series resistor, you'd have your composite output. I began my research by surveying all the circuits that I could find on the web that would make composite or S-Video output. The first one that I found is from the August 1983 issue of Hot Cocoa magazine. There was this article by Martin H. Goodman that showed this magically simple 2-transistor mod. So it picks up 5 volts from pin 11 of the MC1372. It picks up ground from pin 4, and then it takes the modulator output on pin 12 and buffers it with 2 emitter followers, so just a voltage buffer, and then drives into a series output impedance. I'm not sure why it was 22 rather than 75 ohms, but this value can be experimented with, and 75 ohms seemed as good as any. Now, many people have tried to use this on the CoCo 2 and they didn't have any success with it. And the reason is, remember when we were looking at the CoCo 1, it had the 1372 in the non-inverted mode, and in the CoCo 2, the 1372 is inside the RF modulator. It's being used in LC tank mode for RF modulation, and it's not in either of the modes where pin 12 would be just a direct output that can go to a composite circuit. So this so this circuit would never work on a CoCo 2 without some significant changes in the RF modulator first. I found this circuit, and I'm pretty sure this needs to say pin 11 and this needs to say pin 12, because pin 11 is the 5-volt VCC and pin 12 is the modulator output. And notice it matches the first circuit. If you look, if this was pin 12, it goes through the 2 emitter followers and the 22 ohms, and that's composite out. It adds a monochrome out, and that's just by taking the raw luminance signal that came in from the 6847 and going through a couple of amplifiers and creating a black and white version based just off the luminance plus synchronization signal on pin 9. And then here is the sound signal. This comes from pin 3 on the RF modulator, and this is the signal from the main board, and it just goes through a series resistor to the audio output. Here's the circuit that I took from the 6847 datasheet, and this is the one that all the basic composite mods are based on, and mine as well. Then there is the work that the Zipster did. Let's take a look at his website. He has two boards, he has two versions of board. There's his original composite output board, and it's that same circuit from the 6847 data sheet. And he says he's tested that and it looks pretty good. And he has a new version of the board. But it requires a significant modification to the case. I didn't want to do this, so I took a look at his second board. Now here he found a CoCo 2 that had a factory installed mod for composite output and black and white output. And he says that this was used in some educational focused models that were sold to schools. So he made a copy of this circuit and he's reproducing the boards, and I think you can buy one of these today. And he sells the version for either the flat mounted, like in the later CoCo 2s, or he has the vertical mounted that was in the early CoCo 2s. And he says that the output appears to be very good and considerably better than that circuit from the 6847 data sheet. Now I don't know what circuit he's using. Here's the new board that's based on that circuit, but I suspect that it's very close to the CoCo 1 schematic reference that I showed you earlier, where it's based on a higher VCC of 7 volts and a larger load resistor attached to the pin 12 output of the 1372. And the reason I think this is that this new board requires pickup of some external voltages straight off of the main board. So I think it's taking a higher voltage source and then regulating it down to the 7-volt rail, and it's creating a potentially stronger pin 12 output. So this board will output, so his latest board, as far as I know, will output composite video or black and white. If you toggle the channel 3/4 selector switch, it switches back and forth into black and white output. However, I wanted S-Video, and the reason is it's a much sharper picture, as you'll see here a little bit later in my video when I compare composite video to S-Video. Okay, then I found this. I found this very late in my investigation, but it shows an approach toward creating S-Video. And it's basically, it's taking the old circuit from the 6847's data sheet, but just sort of repurposing it using a different load value here, and then repurposing it toward creating a Y only signal, or luminance only, for the S-Video connector. And then the chroma signal is coming off of the pin 8 output. Remember, we saw that pin 8 is the combination of the channel A color, the A reference color and the B color. That's output on pin 8. And if you don't feed that back into pin 10, or even if you do, you can take off of pin 8 and buffer it with an emitter follower, and then send that out to the chrominance pin on the S-Video. And S-Video, like we said, it stands for separate video, and really in its essence, it's just taking the composite signal before the luminance and chrominance were combined. It's just keeping them separate. So it's separate video, so that you get a pair of signals for luminance and a pair of signals for chroma. Now, I didn't end up using this circuit because I was taking a different approach. In my mod of my later CoCo 2, I used pin 12 with the first circuit that I'm showing for composite output. So I have a composite output on pin 12 that goes to a totally separate connector. And then separately, I take the pin 8 chroma and the pin 9 chroma. Then separately I take the pin 8 chroma and the pin 9 luminance, and I separately buffer those and bring those to the S-Video connector. So in my second mod that I'm going to show you, I have a completely separate composite output on pin 12. You can send that to one monitor, and you can also at the same time drive a second monitor with S-Video, and the two circuits do not load each other, and there's no dimming of either picture. Now you'd probably never really benefit from having two copies at the same time, but this is just the way that I chose to implement it in my mod, because I already had a circuit to make composite video on pin 12 from pin 12, because that came from the 6847 data sheet, and then I wanted to separately try a S-Video mod over here based off of just pin 8 and pin 9. I'm going to show you that in a minute. Now, for what I'm calling the second way of creating a composite output, you can simply take the Y and the C and couple them with a 470 picofarad capacitor and tie that, and that's composite output. And you can either do that in the mod. You could put the capacitor right here and then change this to an RCA connector and go straight out to composite. However, that capacitor eliminates the ability to have separate video, or S-Video. So there's another circuit where I'll show you there's a diode and a capacitor, and then you can have both. If there's no load connected to the, you can have both a S-Video connector and a composite connector. If there's no load on the composite connector, then there's no current flowing through the diode and the capacitor, and you can still use the S-Video output. If you then want to use composite, you just simply connect a composite cable and connect it to the CRT or TV. And however, you cannot have both outputs at the same time with that version. So my second composite mod, in the way that I'm going to create it, I'm going to create an external cable. I'm going to make the mod in the cable. So I'll have S-Video coming out, I'll place the capacitor in line in the cable, and then immediately convert over to a single wire RCA cable. And that way, if you want, you would normally, so in that way, most of the time you'll use an S-Video cable for its sharper video capability. But if you have a game that's based on artifacts, or you need to switch into P mode 4 and see artifact colors, then you can just switch over to a composite video cable and go into composite mode. And here lately, the Retro channel came out with a CoCo 1 mod. This is the circuit that he showed on that video during Septandy, and it doesn't show all the connections to the 1372, but remember this chip is on the main board in the CoCo 1, and he's showing how to pick up straight from pin 9, and this becomes the Luma output, and then the Chroma output on pin 8 goes straight out to the Chroma. So the Y and the C are the S-Video connections, and then here is the second version of composite video that I was talking about, where you take the Luma, Chroma, and just capacitively couple them with a 470 picofarad capacitor. This diode is the key to not ruining the S-Video output with this capacitor. So if there's no load connected to the composite output, there's insignificant current flowing through here, so the Luma signal does not inject much into the Chroma, and you get clean S-Video. However, if you want composite output, you would then connect this cable here into the load of the monitor. Now there's current flowing through the diode, and this is a voltage source that then capacitively couples the Chroma into the Luma and gives you the composite output. So this is all I was able to find looking around online, and in the end I was curious about the possibly stronger composite output mod that was in that educational based CoCo 2, but I ended up implementing the first one that I found, which came from the 6847 datasheet, and it makes a pretty decent composite output. However, I really wanted to have S-Video, so I'll show you the two options that you have. You can either have composite only, or you can have composite and S-Video. Now it's time to look at the mods and the schematics. This was my RF modulator that was rusty and corroded, and I didn't really care if I ruined it by modifying it, so I started with this one. And you can actually make your circuit on a clean piece of perf board if you'd like, or if you have an RF modulator that's not working like mine was, you might as well, what do you have to lose, right? So just in case, as I removed the unnecessary components, I did go ahead and keep them because I didn't know if I'd want to reuse pieces of them later. So I was pretty careful about using the solder sucker and removing all the unnecessary components. And this is the mod. This is composite video only, and I left the original video output connector, but you have the option of using a fresh one if you'd like, and then you'll need a audio connector. One other option that you do have is you could use one of these 2-pole or 3-pole TRS or TRS 3.5 millimeter jacks, and you would only need one position. You could place, you could remove this and you could use this connector instead. And I'm going to use one of these in my second mod that I'm going to show you. But here I just have video out and audio out. And I'll show some zoomed photos of this a little bit later. So just briefly, here is the circuit. So this is the pin 12. This is the 6847 reference circuit that we already talked about. This is the audio output through a 0.1 microfarad cap and a 3.9K resistor to this red RCA jack. The tank circuit has been removed and replaced with a forward bias diode from pin 14 to 13. The chrominance output is looped back in, and I've modified this resistor value, and it comes into pin 10, and the Luma on 9 with the sync embedded in it is combined with pin 10, and that's output on the RF pin 12 and then amplified by this BJT amplifier circuit. One other very important mod was to add a bulk capacitor. There's a 100 microfarad capacitor here, and I've also reduced down to one inline inductor or coil. Here is a markup of the original schematic. It's just showing components that I removed, and if these schematics don't come out super clear in the video, I'll have links to them that I'll add in the description underneath the video. But it just shows all the components that you need to remove and where to place the two new transistors. You can reuse some existing component locations, and so I've marked the components in X's that are completely removed. There are some areas that are sort of optional to remove. You only need to remove this area and this large area here. Well, you always have to remove at least the C6 capacitor or R7 to isolate any of this, so you're not injecting anything into the chroma input. But a lot of the circuit is optional to remove. And to go along with the schematic, there is my layout drawing where I've marked all the components that match up with that original RF modulator schematic. Again, this was the early CoCo 2 with the vertically mounted RF modulator, and you can do this mod on either the early one or the later one. Now on to the later model of RF modulator and the mod that I made on it for both composite output and S-Video output. So the note here is that add this circuit to the other changes that were made for the composite video mod. So you still need the diode, you need all these changes. The circuit on pin 12 being the composite video, that's optional. If you only wanted S-Video for some reason, you could omit the pin 12 circuit. You could implement the S-Video circuit that I'm showing here, and then if you still wanted composite video, you could use my method 2 that I talked about, which is combining the luminance and chrominance in a cable or with a diode capacitor circuit that I talked about earlier. But in my RF modulator, I've implemented both. So I have composite video and audio routed out to this 3.5mm TRS jack. So I can use a yellow and black cable or a yellow and red RCA cable. You can even plug in a 3 RCA connector, the red, yellow, and the white, red, and yellow. And in any case, the way I did this, you'll just have mono sound because I only routed the sound connection to one of the poles. But so I have composite video and S-Video. Here's the S-Video circuit that I used. I used an AC coupled BJT inverting amplifier and followed by an emitter follower to drive this from the low side. And here are the component values, and I actually used some slightly different values that I marked here in my notes. They're not super sensitive to the values, but the main thing that's going on here is that this first amplifier is inverting and doubling the signal based on the ratio of R4 to R3. So I think in this actual circuit mod, I think I probably used a 1K and a 500 ohm, and I noted that here. Then this is so that was the luminance, the 75 ohm resistor, and this goes right over to the S-Video connector. And over here is the chrominance. I did go ahead and buffer it with an emitter follower. In the one web reference that I showed you from the retro channel, there was not a buffer here, but I decided to go ahead and add this buffer. And this is the chrominance for the S-Video connector. Here are connectors, and I'll put links and part numbers to all of these. I think I purchased all of these on Amazon. Here's a PCB or board mountable or even panel mountable S-Video connector. That's what I installed here. I opened up, well, first I desoldered the old RF output jack, RCA jack off of there. I rounded out the opening to, I think it was 7/16, and I epoxied this connector in place so that it couldn't move. This will probably show up better in a zoomed in photo, but the shield connection of the S-Video connector is soldered on the side here, on the inside of the metal enclosure. The whole enclosure is at ground. And in fact, that's the only way that the circuit gets a ground connection, is through the soldered connection points from the main circuit board. So with zoomed in photos that I'll show later, you can get a clear view of how I made the mod. But basically what's going on is I have a little mini perf board over here that implements that first circuit that I showed for composite output, and that's based off of the pin 12. And then this area is implementing the luminance circuit. And finally, there is another transistor here that's the chrominance buffer. I also saved all my components that I removed from that original RF modulator, and I haven't really had a need for them, but I thought just to be safe, in case I need to go backwards. I didn't destroy anything, so I didn't even change the tuning of the old inductor and cap. Okay, so we mentioned the S-Video connector. Then here are two different options for the TRS connector. It's a 2-pole plus common, or the TRRS, which is a 3-pole plus common. And you can still use the 3-pole or the 2-pole connectors in either one of these. You just may have only mono audio. However, the CoCo only has mono audio to start with, so you're not really giving up much there. So you have some options. I did go ahead and use this one in my mod, and I'll have links to these parts in the description. And just like with the other circuit, here is now this is the schematic for the newer version of the RF modulator, and a markup of all the changes that I made for the S-Video and its connector. And I noted this is the same mod from the other markup for composite video. Otherwise, the changes are basically the same. I think this value has also been changed to a 680. I just happened to notice that, to 680 ohms. And again, the addition of a bulk capacitor that really cleaned up the waveforms significantly. And I'm showing here how I'm reducing down to a single inline inductor coil. So I remove this one and I move this component here, and mainly because I can read the value of this one. It's I'm showing 10 microhenry inductor, and then of course you want to jump over the old location of L3. There's one more mod. If I forget to mention it later, I'll just say it here just in case. The Y signal comes off of the main board, and I found that there's a small 150 picofarad capacitor on the main board that filters the Y signal to ground. And I got a sharper composite video image by removing that capacitor from the main board. I don't think it has any effect on the S-Video, but you will probably notice sharper composite video by removing that capacitor. And as before, for the other circuit, here is the layout drawing that shows the component locations. Notice that this image has been mirrored like that so that everything lines up with the top side image. Okay, now we're ready to put the covers on these CoCo 2s and do the display tests. So the older CoCo 2 is on the left and the newer one is on the right. Okay, and here is the new audio connector that's in the old channel select location, and I did have to round out the opening. I wanted to keep it to only minor modifications as much as possible, and that was about as much as I wanted to tolerate for modifying on the case. So the other option would have been to, in this location, you can put a combined audio and video connector with the 3.5 millimeter. So you have some options there. And now to put the case on the newer CoCo 2. Okay, and both of these ports are new. So we have the S-Video in the old 2 TV location where the RF output was, and we now have the TRS connector for composite video and sound. Hey, now we're ready to look at the video quality, but let me first point out 2 very important mods that you'll want to know about. First of all, on the RF modulator board, the little PCB, there's not enough bulk capacitance for this new circuit. So make sure you apply between a 100 microfarad and 220 microfarad bulk cap. That's on the schematic that I showed. And 2, I mentioned it earlier, but there's a small 150 picofarad capacitor on the luminance line on the main board of the CoCo 2. And on the old board, it's C59. On the newer Rev A board, it's C23. And it's not critical and not required by any means, but I just noticed slightly improved luminance quality when I removed that capacitor. Just slightly sharpened the edges of the waveform of the luminance pulse, so that that's not filtered and rounded off as much as it was before. And we're ready for the video quality test now, and I'm going to try to shoot this in one continuous shot so that lighting doesn't change, camera angles do not change too much. And when I test the old CoCo mod, I'm going to be using the video cable and probably the white connector. Yes, so yellow and white on this style of cable. And then when we test the newer mod, I'll first test the composite video and the audio with this style of cable, the 3.5 millimeter jack to the red and white. I'll use white for video and red for audio. And then for testing S-Video on that same computer, I'll of course use an S-Video cable. And I'll leave the 3.5 millimeter in place so that I also have audio. So let's begin with the older CoCo 2. There's video There's audio. Make the same in the back of the monitor. Okay, and the test will be, we'll boot to the basic screen and look at the black text on green, and then we'll use these two cartridge games. First, Canyon Climber, because Canyon Climber is a game that depends on artifact colors, and we want to see especially how that affects the composite versus S-Video mode. Because we know that in S-Video we don't get the mixing of the vertical bars, so we are not able to generate artifact colors. So it'll be very interesting to see how that responds to S-Video. And then Dragonfire is another high resolution graphics game, but it does not rely on artifact colors. So that's why I've chosen these two. Alright, and let's boot to the basic screen. So there is Composite Video. And I'm going to just type in the same small program for each of these tests. There we go. And I would say this is not perfect composite output. I think there's a little bit of room for improvement. It's just a little bit fuzzy or blurry. And I found that the graphics modes look a lot better in composite mode than the text does. So first we'll try Canyon Climber. And there's the blue screen. Now let's restart until we get the orange screen. There's the orange screen. And earlier I did play with the tint on two different monitors. With different monitors it comes across as different shades of orange, and you can make it more toward the yellow or more toward the pink. Now let's try Dragonfire. And there's our first chance to hear the sound. There are not a lot of great sound effects in this game, but at least the sound's working. And again, around text, it's a little blurry. And that's the main reason that I really wanted to have S-Video mode in this CoCo mod. So let's move to the newer CoCo 2 and take a look at its composite output. Okay, so we'll plug in the 3.5mm jack for the composite video and audio. Okay, and we'll see the basic screen. Not too bad. Again, a little room for improvement on the composite mode. And in the future, I'll probably do another look at the other circuit for composite video that we saw in the CoCo 1 schematic. But this is pretty good. It's probably as good as the old RF modulator, and at least it doesn't have that static interference in it that came from touching the case. Okay, now let's try Canyon Climber. And we fully expect artifact colors to look good in this game with this mod. Okay, and it does have good artifact colors. It's a very nice looking screen, and the game is quite playable. It looks good to me. And let's repower until we get the orange screen, or the orange sky. There's the orange. Okay, now let's try the S-Video version of outputs. Or let's try Dragonfire, sorry. Jumping ahead. Once again, that looks good. There's good sound. Okay, and now let's move to the S-Video check. So I'm going to leave the 3.5mm in place so that I still have audio. And with my particular monitor, if it detects S-Video and composite video, it up-selects automatically to the S-Video. And if you pull the S-Video, then it'll go ahead and down-select to the composite. So we can leave both cables connected, and we should start up to in S-Video and to the basic screen. And that looks really nice to me. That is so much clearer than the composite. I hope you can see that in the video. I hope that comes through. And I believe it is. I see that there's a little bit of flicker in the recording that's not actually present in real life, but I think the clarity of that text is coming through. Definitely much clearer than the composite, don't you think? Okay, now let's try Canyon Climber. Again, this is, what is it, P Mode 4 graphics. It depends on artifact colors. So we should see the vertical black and white stripes. See that? There was that orange flash when it was in a certain graphics mode and the background went solid orange. And then it changed to this P Mode 4, and the striping is not able to produce color because it's not getting mixed. The luminance, or I'm sorry, the chrominance is not getting mixed with luminance at any point in the signal chain. So the luminance and chrominance are separate all the way out to the monitor. And there's no point in there in which the artifacts can be generated. Pretty cool. All right, and that is quite clear. This text, there's just the slightest bit of ghosting. It's not really noticeable though. This is just really clear text. And finally, for Dragonfire, and here's where you'll get to notice that the sound is still in effect. So the S-Video is being chosen by the TV for the video, and here's the sound. Yeah, it's picking up the sound from the one of these two wires here. Wow, that's very clear. It's very easy to read the text now. And let's watch what happens when we pull the S-Video connection from the TV. It should detect that and then find there's still composite. There we go, and it switched over to the composite input. And if I reconnect S-Video, it's going to up-select back to the S-Video. There we go. All right, I hope you enjoyed that. This has been great to see the different video quality from the earlier video that I made with the RF Modulator with all of its static. And I think the new composite mod is just about on par with that, and without needing to have the old analog RF tuner in a TV. And there's no potentiometer resistors to have to adjust in this new circuit. And right before we finish up this video, I thought you might want to have one final look at things with the covers off. So let me get just a little bit of some close-up here. I noticed there's a I have a wire there that I forgot to trim. Wow. Yeah, I totally forgot to trim that lead. Fortunately, it was not touching anything. Where I'm pointing to, I'm trying to point to this little lead right here that I just forgot to trim. Okay, and then here's the other side, the component side of the board. And there's the view of the connectors from the top. By the way, when you have the cover off on this old one, this is mains voltage right back here. So the whole time I was working on this, I kept this covered with first a layer of electrical tape and then a layer of duct tape over that. The newer CoCo 2 has this nice electrical cage, the safety cage. I really like that feature. And here's a look at the, this is really just temporary the way I've done this. That's an old, that's a Chinese copy of a Lego brick, and it's just super glued together right now. There are probably some options on how to do that, but that was just my first quick way to connect that. And there's the S-Video connector there. This is again a TRS 3.5mm jack for the composite and audio. And I just gave myself gave it a little place to put a cable tie just to do to provide some strain relief for these two cables so that I don't break a connection back here at the solder points. And I would like to just mention that these CoCo 2s are a dream to work on. As far as opening them, removing covers, it's just, everything is really nicely built and assembled, and I like the way it's put together. The only one thing that gave me a little bit of hesitation was the flex strip type of ribbon cable, the flex strip cable connection for the keyboard. And I haven't had a problem with it yet. I was just very wary of pulling that out of the connector. It really held fast the first time I tried to remove it. And I was worried about how it would go back in, but it actually went in much easier than it pulled out. So that's okay, but I really liked working on this. It was easy to power the CoCo because it uses AC plug, and just very well put together and easy to reassemble everything. Okay, and about the second type of composite output, this is the way to create composite output from your S-Video output. I have not made the cable yet, but I want to make a cable of this style on the right. This is a permanent conversion to composite. In other words, once this capacitor has connected the luma to the chroma, then we can no longer use this as a luma and a separate chroma signal. So this is the kind of mod that you would want to put inside a cable, so it's temporary. So as soon as you disconnect the cable from the CoCo, then the CoCo is available to generate the luma and chroma. Now over on the left, this is more of an on-demand approach. By adding this diode, the capacitor is only coupling chroma into this node when there's load or current flowing through this diode. So only when the monitor is connected and presenting this 75 ohm load is current flowing. And when that is flowing, this is a voltage source here, and this capacitor can couple into that. So when the monitor is disconnected, then there's very little current flowing through this diode and capacitor, and we have separate luma and chroma again. So I've tried both of these on the bench and they do work, and this is the kind that you would want to use if you created a mod where you had a composite connector at the same time it had a S-Video connector, and you wanted to drive either or at one at a time. And this is the kind of mod that you would put inside a cable where it's not permanent, so that after you remove the cable, your S-Video connection is available again. Okay, and that wraps things up. I hope you enjoyed that, and I hope a couple people find this useful. And if you have any questions or anything was unclear, definitely let me know. Also, leave any other comments you'd like. If you like this, give me a thumbs up, and don't forget to subscribe for more content coming up soon, much like this. And until next time, see you then.